how much does it keep you up at night? The bottlenecks in the supply chain of AI, like ASML with EUV lithography machines, TSMC with advanced packaging like CoWoS, and SK Hynix with high bandwidth memory.
All the time. And we're working on it all the time. No company in history has ever grown at a scale that we're growing while accelerating that growth. It's incredible.
Yeah.
And it's hard for people to even understand this. In the overall world of AI computing, we're increasing share. And so supply chain, upstream and downstream, are really important to us. I spend a lot of time informing all the CEOs that I work with, what are the dynamics that's going to cause the growth to continue or even accelerate. It's part of the reasons why to the entire right-hand side of me, we're CEOs of practically the entire IT industry upstream and practically the entire infrastructure industry downstream.
Mm-hmm.
And there were several hundred CEOs. And I don't think there's ever been keynotes where several hundred CEOs show up. And part of it is I'm telling them about our business condition now. I'm telling them about the growth drivers in the very near future and what's happening. And I'm also describing where we're going to go next so that they could use all of this information and all of the dynamics that are here to inform how they want to invest. And so I inform them that way, like I inform my own employees. And then, of course, then I make trips out to them and make sure that, hey, listen, I want you to know this quarter, this coming year, this next year, these things are going to happen. And if you look at the CEOs of the DRAM industry, the number one DRAM in the world was DDR memory for CPUs in data centers. About 3 years ago, I was able to convince several of the CEOs that even though at the time HBM memory was used quite scarcely, and barely by supercomputers, that this was going to be a mainstream memory for data centers in the future. And at first it sounded ridiculous, but several of the CEOs believed me and decided to invest in building HBM memories. Another memory was rather odd to put into a data center is the low power memories that we use for cell phones. And we wanted them to adapt them for supercomputers in the data center. And they go, cell phone memory for supercomputers?
Mm-hmm.
And I explained to them why. Well, look at these two memories, LPDDR5, HBM4. The volumes are so incredible. All three of them had record years in history. And these are 45-year companies. And so, that's part of my job is to inform and shape, inspire,
So you're not just manifesting the future and maybe inspiring NVIDIA, the different engineers of the company. You're manifesting the supply chain of the future. So you're having conversations with TSMC, with ASML.
Upstream, downstream.
Upstream, downstream. So that's the thing.
GEV, Caterpillar. Yeah, that's downstream from us.
Yeah.
Yeah. There you go.
The whole thing. I mean, but there's so much incredibly difficult engineering that happens in the entire semiconductor industry. And it just feels scary how intricate the supply chain is, how many components there are, but it works somehow.
Exactly. The deep science, the deep engineering, the incredible manufacturing, and so much of the manufacturing is already robotics. But we have a couple of hundred suppliers that contribute the technology that goes into our 1.3 million component rack. Mm-hmm. Each rack is 1.5 million components. There are 200 suppliers across the Vera Rubin rack.
So it's interesting that you don't list that as the thing that keeps you up at night in the list of blockers.
But I'm doing all the things necessary to.
Okay.
Yeah. See, I can go to sleep because I checked it off. I said, okay, I can go to sleep and I go, well, let's see let's reason about this. What's important for us? Mm-hmm. Let's reason about this. Because we changed the system architecture from the original DGX1 that you remembered to NVLink 72 rack scale computing. Mm-hmm. What does that mean? What does that mean to software? What does that mean to engineering? What does that mean to how we design and test? And what does that mean to the supply chain? Well, one of the things that it meant was we moved supercomputer integration at the data center into supercomputer manufacturing in the supply chain.
Mm-hmm.
If you're doing that, you also have to recognize you're going to move one, and if your total footprint of whatever data center you're going to build, let's say you would like to have 50 gigawatts of supercomputers that are running simultaneously, and it takes 1 week to manufacture that 50 gigawatts of supercomputers, then each week in the supply chain, the supercomputers are going to need a gigawatt of power. And so we're going to need the supply chain to increase the amount of power it has to build and test the supercomputers in the supply chain before I ship it. Mm-hmm. Well, NVLink 72 literally builds supercomputers in the supply chain and ships them 2-3 tons at a time per rack. It used to be, they used to come in parts and we used to assemble them inside the data center. But that's impossible now because NVLink 72 is so dense. And so that's an example. And I would have to go into, I fly into the supply chain, go meet my partners and hey, I said, guess what? So here's what we're going to do with, this is the way we used to build our DGXs. We're going to build them this way. This is going to be so much better because we're going to need them for inference. The market for inference is, coming. The inflection point for inference is coming. It's going to be a big market. And so I first explain to them what's going on, why it's going to happen. And then I ask them to make several $1 billion of capital investments each. And because they trust me and I'm very respectful of them, and I give them every opportunity to question me, and I spend time to explain things to people, and I reason about it. I draw them pictures and I reason about it in first principles. And by the time I'm done with them, there's know what to do.
So it's a lot of it's about relationships and building a shared view of the future.
Yeah.
But do you worry about certain bottlenecks? I mean, what are the biggest bottlenecks in the supply chain? Are you worried about it? ASML's EUV tooling? Are you worried about the packaging, CoWoS packaging of TSMC? About how fast it could scale? Like you said, you're not only growing incredibly fast, you're accelerating in growth. So it feels like everybody in the supply chain, and those are certainly bottlenecks, would have to scale up. Are you having conversations with them? Like, how can you scale this faster? Time. Do you worry about it?
No.
Okay.
Because I told them what I needed. They understood what I need. They told me what they're going to go do, and I believe in what they're going to do.